I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for Unit 5, Lesson 3. We're going to talk about solving systems of equations using elimination. In order to use elimination, what you're going to do is you're going to use addition or subtraction to eliminate one of the variables, x or y. In order to do this, the coefficients must be the same or the opposite. So let's look at some examples. So here I have a system of equations. I want you to notice that this system is in standard, both of these are in standard form, which looks like this. That is standard form. And because they're both in standard form, the x's and the y's are lined up, which is what we want. So if you see two equations in standard form, you should probably try to eliminate before you try another method. So the coefficients need to be the same or opposite. The coefficient of this x is a 1. Remember, that's an invisible 1. So I've got a 1, a 5, and then a -2 and a 2. So those are opposites. So what I need to figure out is, how can I make this column be 0? Do I add or subtract? I would need to add, because -2 plus 2 is 0. So I'm going to put a big plus sign here. So all I'm going to do now is I'm going to add the columns. And I need to make sure I add all 3 columns. 1 plus 5 is 6x. The 0, just, that's 0, so it cancels out. Equals -19 plus 1 is -18. To solve for x, I divide by 6 on both sides. X equals -3. Remember, a solution to a system of equations is the point of intersection, and a point has an x value and a y value. I have my x value, that's -3. Now I need to go find my y. So I'm going to rewrite my first equation, and I'm going to plug in my x value for x, and then I'm going to solve for y. So I'm going to add 3 to both sides. So -2y equals -16. Divide by -2 on both sides, y equals 8. So this is my solution to the system using elimination. The next example, again, I have the x's and the y's lined up, so that looks good. I'm looking for the same or opposite coefficient. So I see that these have the same coefficient exactly, 4 and 4. How do I make that equal to 0? This time I have to subtract. Why? Because 4 plus 4 is 8, and I don't want 8, I want 0. So I have to subtract in order for that to be 0. So what is 3 minus -2? 3 minus -2 is the same as 3 plus 2, which is 5. So this is 5x. 18 minus 8 is 10. Divide by 5 on both sides, x equals 2. So again, I have half of my answer. So now I need to go back to my original equation. Either one, it doesn't matter which equation you use because it should work for both. If it doesn't work for both, then it's not the solution. I'm going to plug in this 2 here. So 3 times 2 plus 4y equals 18. That's 6 plus 4y equals 18. Minus 6 on both sides. 4y equals 12. Divide by 4. Y equals 3. So the solution is 2, 3. Now you can also use elimination even if the coefficients are not the same or opposite by multiplying one of the equations by a value. So I notice I have a 2 and I have a -1 here. That's a 1. And then I have a 1 and a 3. Well, I can multiply 1 times anything to get whatever I want. So what I'm going to do is I'm going to multiply this bottom equation by 2. And if I do that, this first term, 2 times -x, is now going to become -2x, which is opposite of 2x, which will allow me to eliminate. 2 times 3y is 6y, and 2 times -12 is -24. Make sure that you distribute this all the way across. So then I'm going to rewrite my first equation, which was 2x plus y equals 3. Now, am I going to add or subtract? Again, I want this column to be 0, and in order for that to happen, I need to add because they are opposite signs. -2 plus 2 is 0. 6 plus 1 is 7y. Negative 24 plus 3 is negative 21. Divide by 7, y equals negative 3. So this time I have y first. Now I need to go and find my x. So again, I'm going to write the first equation just because that's what I always do. 2x plus y equals 3. I'm going to substitute this negative 3 in for this y because that's what it is. 2x plus negative 3 equals 3. Now 2x plus negative 3 is the same as 2x minus 3 equals 3. Add 3 to both sides. 2x equals 6. Divide by 2, x equals 3. So the answer is 3, negative 3. That is the point where those two lines are going to intersect. Let's look at one last example here. I have a 1 in front of this x and a 1 in front of this x. So if I want that to be 0, I need to subtract. So 1 minus 1 is 0x. 4 minus 4 is also 0, 0y. And 2 minus 10 is negative 8. So I'm left with 0 equals negative 8. I don't have a variable. Remember, this is not a true statement. Therefore, the answer would be no solution, which means that these lines are going to be parallel lines, which means they have the same slope. If you are using elimination to solve and you get, after you do the work, you get down to, for instance, 3 equals 3, then you know that the answer would be infinitely many solutions. So that's how those are going to look different, the two kind of special cases. So if your variable disappears, it's going to be one of those two answers. You just need to check if the equation, what you have left is true or not. And most likely, actually, what you'll get is 0 equals 0 is probably what you'll get, and that means that it's infinitely many solutions.
I've been waiting way too long. Yeah.